In homework 7, question number 7, we're given z of t, and it's a random process that is about t and a random variable theta, where theta is uniformly distributed in 0 to 2 pi. And 1 of t and 2 of t are Whiteson stationary, and also we're given that n of t and theta are all independent. We're asked to find expectation of z of t in the first problem. So what we can do here is pretty much, so because so we put the function, the expression inside this expectation, right? And then e of n1 of t is because n1 of t and n2 of t, they're WSS, so they have a mean that is a constant number. So we can just take that e of n1 of t outside of the expectation, because a constant within a e and outside a e is the same. And then by doing a little multiplication, we pretty much expand the cosine omega c t plus theta here, and we have this long expression. And after extracting n1 of t and n2 of t outside of this huge brackets, we get the following result here. Yeah, and we can see we need to find out the expectation of cosine theta and expectation of sine theta. And it's relatively easy to calculate the expectation of those two things. Because the definition of expectation is given as this integral of this expectation, this you can say this function here, and then the probability density function of theta given here. And because cosine theta is a periodic function, and it repeats itself every 2 pi, so we have here like 2 pi, the value of sine theta when theta is 2 pi and 0 would be the same, and that will result an expectation of 0 for this expectation of cosine theta. Same for sine theta. So we can see like there are 4 terms here, and in each term there's either an expectation of cosine theta or an expectation of sine theta. So each of the 4 terms will result in 0, and that will give us the expectation of z of t, which is also 0 in the end. And secondly, we're asked to find the autocorrelation of T1, T2. And we're also asked to find out if z of t is also WSS. Okay, so autocorrelation of RZ of T1 and T2 is given here. So expectation of z of T1 times z of T2, right? And then we can just multiply the expression. So here we're given the expression. So we need 2 different t's here, and after multiplying that, we get this result here. So pretty much we have this n1 of t1 times n1 of t2, n1 of t1 times n2 of t2, n2 t1, n1 t2, and so on, n2 t2, and n2 of t1 and n2 of t2. Yeah, and so when we do multiplication, so there will be like two cosine times cosine, cosine times sine, sine times cosine, and sine times sine. So we have this really long expression here. And we can take these two parts out, the constant part. Yeah. And the reason why we can take it out of the expectation is that they're constant and was explained already in the last problem. So here we have this we can call it coefficients for now. Yeah. And because n of t is WSS, the autocorrelation only has to do with the difference of t1 and t2 here. And this expression can be transformed into this. The autocorrelation of n1 of tau. Tau is the difference between t1 and t2. All right. And then inside cosine times cosine, and this n1 and n2 are the two different means. Cosine times sine, same here. Sine times cosine, and the autocorrelation in 2 of tau. Inside here is sine times sine. And here we actually need to make use of like some of the formula, triangular transformation. Yeah, so cosine times cosine can be transformed into half of the sum of cosine plus the subtraction of cosine. Yeah, and so every expression has an according formula for transformation, and then we can express all these 4 different expectations in like the summation and the difference of so here omega c t1 plus theta and omega c t2 plus theta. Yeah, and here we get this as a result. So pretty much, so the sum and the difference, tau is given here, t1 minus t2. So the summation and the difference, right? And then we can look at this result accordingly. We already solved in the first problem that e of cosine whatever plus 2 theta will give us a result of 0, expectation of 0, because theta is periodic. Yeah, cosine is periodic, and 2 theta here eventually will get like a multiplication of multiple 2 pi's, so that will result in the same value being subtracted, and that will give us 0. And very similarly, the sine here will also give us 0. So these 4 terms here, they're crossed, because they're 0. And let's look at the second half. So a half of sine omega c tau and minus, so here minus a half of sine omega c tau. Well, these 2 terms are canceled out. So we eventually only have a half of autocorrelation n1 of tau times cosine omega c tau. And then also here, the 2 minus sign will give us a plus. plus a half of autocorrelation n2 of tau times cosine omega c tau. So eventually we have a result here. So autocorrelation z of t1 and t2 will be looking like this. And that is an expression that is only a function of tau. So yeah. So now we know the autocorrelation RZ only has to do with the difference of two t's. Yeah. And plus we already know from the first question that it has a mean of 0. So z of t is MSS. Sorry. WSS. Sorry, just let me change that. The third question is relatively easy. We just need to plug in the 0 in it, and then we'll have half of expectation of n1 of t squared plus expectation of n2 of t squared.